Hi guys. Alright, so today we'll be looking at graphical user interfaces, and for a lot of people it's the most exciting part about programming, being able to put up an actual window, and this is outside of a command prompt, which we've been doing over and over in both Python and Java. So now we get to look at a lot of the libraries that are supported by Java, in particular the Swing libraries. So this is part one of the two series for GUI interfaces, and we start off by looking at the text-based examples that we've been using all throughout this course, and that's what we call the command line interface, or the CLIs. Now this is most of the primary interface that most beginners interact with, and in my opinion it makes programming a lot more boring, right? Because you only have the option of typing in commands, entering options, and so on. But with GUI you have a lot more interesting ways of exploring the screen, exploring the user interfaces, and getting stuff done. So you've also done text-based menu applications where you press 1 for this option, press 2 for that option, and again it's very tedious and boring to build. Now, although it serves as a good starting point, because now you understand a lot of the fundamentals required for programming. You'll have you better understand object-oriented programming when we start you off like that. But no, given you have a strong foundation, and I hope that you guys are practicing, but with that foundation we can now introduce you to more interesting ways of interacting with your users. So on your screen you're seeing the first example of what we call an open dialog box. And we'll get more into that, but most modern computers have some form of rendering these graphical user interfaces. It's also interesting because the Swing library is common across all platforms. So whether you use an Apple device, or a Mac, or whether you use a Windows-based device or Linux, there's a Swing library that you can use, and it will render almost the same across all of these different OSs. So one example of open dialog is the one on screen. That is pretty common when you open up Microsoft Office-based products. So this is in Microsoft Word. And whenever you type information into these boxes and make choices, it brings you further into the program. So this lecture aims to expose you to these GUIs and ways of representing more options to your users. The first thing that we'll be looking on are GUI containers and components. So these are primarily the things that hold other objects and kind of put them together in an organized fashion. So this is one example of a GUI. Now, the first, or the parent item that is usually rendered is the frame. And the frame is everything in this area. It contains all the components, right? Whether the components are containers themselves, or even a label as shown here, or a text field, and so on. So all of these items are laid out on top of these frames. So if you think about the layouts, the first thing that you'll have is a frame. The next thing that you might have is a container containing labels such as the first name label, and what we call a text field such as a JText field, as we'll show you. This is another example of a GUI where we actually have records being rendered on a table. So the first thing again is a J frame, which is highlighted here, And then the next thing that you'll see are several records in a table, right? So that in itself is a component rendered by the Swing library. You can actually have a panel laid out on top of a frame, and in that panel you'll have multiple items. So we'll show you some more of this afterwards, but the next thing is that a GUI component is actually an object that is represented on a screen. So it's a screen element. So if you think about the button that says save or cancel, that is also a GUI component. You also have a text field that you can enter text into, that is also considered a GUI component. So the most used libraries in graphical user interface development are actually the Swing and AWT libraries. It's a little different for web programming, but for desktop programming, the most commonly used libraries are Swing and AWT libraries. So AWT actually stands for the Abstract Windowing Kit, a toolkit, and it was actually the original windowing kit that shipped with Java. So a lot of those components are still used and can be used in conjunction with the Swing libraries and all the different packages in the Swing API. So, but as the development went on, the Swing package became a lot more popular because they featured a lot more advanced ways of interacting and more supported by the different operating systems. Right. The main thing that you guys need to know is that the Swing and AWT libraries are the primary graphical user face libraries that you'll be interacting with, and they're both needed when you're creating these GUI programs. So, a GUI container is actually a component used to hold and organize other components. So those things that you see on the screen, such as a frame or a panel, those are what we consider containers. So the frame is actually a container that is used to display a window, all right? So and you'll encounter a number of those windows. Most of them have certain properties on them. So you have a title bar where you display, the name of your application. You also have, the close button, whether it's on the left or the right, depending on your operating system. All of those are properties of a frame. In Java, they're considered J-frames, and we'll get more into that. But the panel actually doesn't have a lot of those properties. The panels only have just a blank slate. There are no title bars. Nothing is visible, right? But panels are placed on top of frames, and then components are usually placed within them. A couple of properties of GUI containers. There are two types of containers. So there is heavyweight or lightweight. A heavyweight container is what we consider a container that is managed by the operating system. A J-frame is actually a GUI container that is managed by the operating system. So properties such as close and force quit, if you're using Mac OS, is actually managed by your operating system and then tells your Java programmer what has happened. And again, it's another part of the course that we'll cover when we touch event-based programming. But all of those frames that you render are managed by Windows, Linux, or Mac OS. So just a key thing that you need to know. But there are other lightweight containers, such as a panel. All right. So it's important that this distinction between heavyweight and lightweight components be made, and eventually will come up. But the key thing is that one is managed by the operating system and the other is managed by your application itself. So this is actually what we would call the different types of components available across most programming languages. So you have a frame, which is usually the main window of the application. In Java, managed by the swing class, we call that the JFrame. We also have panels. Most languages have their concepts of panels, and if you program in HTML, there are also canvases and so on. The swing class for a component such as a panel is called a JPanel. So it's pretty easy to remember. If you have a frame, it's called a JFrame in the swing library. If you have a panel, it's called a JPanel in the swing. And similarly, you have labels and text buttons and buttons, all called JPanels, JTextFrame, and JButtons. Not too creative here. So there are many other components that you interact with, and you can feel free to explore the swing libraries. They're well documented, and it's a good resource to use, and you'll explore a lot of the idiosyncrasies of these components. So feel free to explore those documents and make use of them. All right, so in Java, a label is a GUI component that is just a line of text, right? So whether you want to say that this particular component will contain the person's first name, you use a label for that kind of thing. So labels are usually used to display these tidbits of information that hint at the use of another component. So right here we'll pause and kind of explore one class called the authority.java class. Now the program isn't interactive as yet, but the frame at minimum can be repositioned and resized. Now that's an important part of the ability to interact with the user. Now if you imagine you have multiple windows on your display, you can actually resize them so that you can accomplish better multitasking. So that's an important way of interacting with your program. That is important in a lot of context. Or the most important libraries that we'll be using are the Swing and AWT libraries. So we start off by importing those libraries as shown here. The next thing is that we're naming this class authority, and it has our main or starter, what do you call it, the main area where we start our program. And in this area, you'll notice that we have a JFrame, and we give it the name authority. Now, JFrames usually taking into their constructor the title of that frame, or what we call the title bar text. So in this case, it will be authority. Right? So the next thing that we want to do is set the default close operation, and this is extremely important. What this does is tell Windows what happens when the X button is clicked, whether it's Windows, Linux, or Mac. All right? So if you click the X button in Windows, it tells your program that it's exiting. All right? So it's setting the default. In this case, it's exiting. You can set the default to do something else. So when you click on X, instead of closing, it actually hides it. If you're a user of Mac OS, when you click on the X button, what actually happens is that you may not want to close the entire program, but you want to hide the window. So it's hidden in the default, taskbar of the operating system. Now, the next thing that you'll notice is that we're creating a JPanel object. Now, the cool thing about these JPanel objects is that you can do anything that you want with them. You can set the color, you can set the size of that panel, and so on. So in this case, what we're doing is setting the color to yellow, setting the dimension to 250, that's the width, by 750 height. All right, so we'll explore more about it, but there's a dimension class in Java that you can use to set sizes. And the mutator that you're seeing here, set preferred size, takes in a dimension object. So we'll explore more about that. Now, there's a JLabel here being created, and in that JLabel, we're setting the text of the JLabel to question authority. And then the second JLabel is but raise your hand first. Okay, so we created two labels and we are now applying them to the panel. So that yellow 250 by 75 panel now has two labels added to them when we add use the add mutator to the primary object. Okay, all right. So now that we have our labels on the panels, we can now put the panel on the frame. All right, and to do that, we have to ask the frame for the content pane and then add the. It's a little convoluted, but it will make sense in the end. Now, the next thing that you'll observe is that we're saying frame.pack. All right, so frame.pack, what it does is kind of sets the window to the panel. All right, so the maximum dimensions of that panel will automatically be the frame size. All right, so there are other things that the pack method does, but for now, what we're doing is setting the size of the frame itself. Now that we've constructed the frame, place the objects on the panel, and then place the panel on the frame, what we want to do is to render it to the user. And we do that by saying set visible. All right, so you'll see I call it the frame.setVisible true. You can also hide that frame by calling set frame.visible and setting it to false. But for now, this is all our program will do. And this is what gets rendered. Now, I'm using macOS, so this is what will be rendered for me, where the close, minimize buttons are rendered to the left. If you're using Windows, expect it to be rendered to the right. Now, that's the beauty about coding in Java. It's what we call a cross-platform. So if I write a code on my macOS, what will happen is that I can send it to somebody that has Windows and render it automatically, appropriately for Windows. So all of those controls will be rendered in the correct location, and that's why we say Java is a portable language. So, right, so we'll get right into it. You'll notice that the JLabels are rendered on the panels, on the yellow panels, and then the panel is placed on the frame. So this is the result of our code. Yeah, not so cutting edge right now, but we'll get it. This example actually demonstrated a few key concepts of Java and GUI programming. So every GUI component has different methods that can kind of be called or invoked in this case to set or query the state. So if you notice that we had setters to set the panel on the frame, and we had getters to get the content pane from the frame in order to add something to it. So there are a lot of different setters, and you guys will need to explore a lot of these methods in the Java docs. So I will encourage you guys to check out the JFrame document, check out how they operate, read about the idiosyncrasies of it, read how pack works, and understand what it does when you call on it, and how to manipulate a window. So if you want it to be invisible, if you want it to be transparent, if you want a panel to be transparent, and so on. So there are a ton load of different methods that you guys can manipulate in order to achieve your objective. What I usually do when I'm designing something is to literally take up pen and paper, draw out how I want the items arranged, and then figure out how to use the code in order to best arrange the elements on the screen. So I encourage you to kind of adopt a similar approach when you're doing a graphical user interface. So an example again of these methods is the set preferred size method. You can use that in order to tell Java that this is the preferred size of that panel, but Java still accommodates resizing. So even though you've set the preferred size, what will happen is that the panel will be first rendered at that preferred size, but your user can go ahead, click on it, and expand it if they want, right? So it's a preference, but it's not necessarily how it will be in the end. So again, as a designer, these are things that you'll have to consider. So explore the documentation, guys. A few things. So you'll notice us doing these chained methods. So using this example, frame.got, using this example, frame.getContentPane.add primary. What that is doing is combining two methods. GetContentPane actually returns a container, but instead of storing the container using some variable, you can just go ahead and just say add whatever you want to that container. You have the option of actually creating an explicit container and storing the content pane in it, and then saying c.add primary. It's really whatever. You know, you could use either methods of accomplishing the same thing. I usually recommend just storing the container if you have multiple things that you want to do to that container. So maybe you want to set a layout to that container as well as add the content to that content pane. So when you're doing multiple things on that one container, I'd usually recommend storing that container in some variable. I would again encourage you guys to go and explore the container swing class. It has some important convenience functions as well. So go and check that out. So another class that becomes really important is the color class. And color spelt the American way. So you drop the U. Alright, so Java for some reason adopted the American standard of English. So a number of the words and keywords in Java are spelled the American way. So you will say C-O-L-O-R instead of C-O-L-O-U-R. So that's something that you guys need to look out for. The color class also comes with some predefined colors. So we used yellow, for instance. Color.yellow will return the primary yellow color. Now, you can use that color class by giving it to the setBackground method. Right. So the color class actually ships with Java. You can do a number of things with the color class. You can also get some of the predefined colors in Java. So one example is the yellow class. By using this, you don't have to focus on on creating your own colors by adding the red, green, and blue and mixing them and doing all of that jazz. You can just use one of the predefined stuff, and they're not the most designer-friendly colors, but you can, if you so desire, you can go ahead and attempt to create the red, green, blue mixes to accomplish whatever colors you guys need. So the setBackground method actually takes in a color object. So you can create your own color object and place it in there, or just use one of the predefined colors in Java. So in this case, what we're doing is setting the panel to a color yellow. Okay. Again, we explored the dimension object previously, but here we're explicitly telling you that you can create your own dimension objects and pass it to panels, pass it to JLabels, pass it to whatever can be resized. Okay? Dimension objects usually have the form width, height, and in this case, we're setting the dimension to 250 by 75, all right, and that's pixels. This is a little old in terms of the way that we set the size in our operating system. There are a lot of different ways now of setting sizes. you also have ways that accommodate for different screen pixel densities. So if you're a big Android fan and you guys rave over the highest pixel density phones, you'll understand a little more about how pixel density works and why I'm saying that there are different ways of setting sizes. You can, if you use Photoshop, you'll realize that you can also set the size in inches, and what Photoshop actually does is recompute it in a way that it can render it to the screen, which is in terms of pixels and pixel density. So by using the set preferred size, again, what we're saying is that we want the size to initially be this, and then the user will have the ability to resize and change the dimensions. Now, a couple points to note. If you're building an application that will be widely used, has a large user base, what happens is that you need to set the size to a size that is acceptable for most users. Not everybody will be running ultra-wide displays that can render 4K images. You also have to consider users that have very old PCs that can probably only spit out 800 by 600. If you guys don't understand what I'm saying, you guys need to understand different resolutions and different screen sizes. So I would encourage you guys to go and read up a little about it. 800 by 600 is an example of how many pixels wide and down you have in terms of screen space. So your application will be constrained to that size. Now, 800 by 600 is actually pretty old. That was probably when I started coding. Now, displays today that usually say they're a 4K display. So what that means is that it can render in this much screen size. So in Java, we have this concept of kind of nesting. If you're a Photoshop user, this is a lot like putting on multiple layers. So panels are pretty useful containers for things, right? So what you can actually do is take one panel and apply multiple different panels within that panel, right? So it's that concept is what we call nesting or nesting of panels or nested panels. So the outcome of nesting a panel allows you to achieve a number of different and interesting graphical user interfaces. Maybe you want one panel to have what we call a card layout, so you have one thing after the other, or maybe you want another panel to have an accordion type layout of objects. So you can vary the different what we call different layouts on each panel in order to accomplish your graphical user interface design method. So containers that contain other components kind of make up this hierarchy of objects. So if you can imagine, you have a top layer being a J-frame, and then the J-frame containing a panel which contains other panels or other components. So it creates this hierarchical structure. I think something like this is better illustrated using the code and running it for you guys. So we have an example here with nested panels.java. So here we go. We create a J-frame. We set the default close operation to exit. And then we create a subpanel. So if you notice the subpanel, the size is 150 width by 100 height, and we're setting the color to green. The next thing that we're doing is setting the label. All right, so we're creating a label and adding it to the subpanel. That label will have the text 1. Continuing, we have a subpanel 2. That subpanel 2 also has a dimension of 150 by 100, but this time the color is red. And we're creating a label with the text 2, TW. Then we're adding this label to a subpanel, All right, so now we have two subpanels, both with a specific set of colors and two different labels. Now, after creating these two subpanels, what we're going to do is place them within a primary panel. So we create an object, a JPanel primary, setting the background on this primary panel to blue, and then adding both subpanels to it. Right, so after doing all of that, if you notice here, we're not setting the size of the primary panel. We're just creating a primary panel and adding the two subpanels, both with 150 by 100 dimensions. So after adding that, the subpanels to it, the next thing that we're going to do is get the content pane from the J-frame and add the primary panel on it. Then pack, and then we set visible. So we create all of these, we do all of these operations, and then the last thing that we usually do is set visible to true. So after creating all of the objects and placing them properly, we usually render it to the screen. Now this is a result of what we did. The top window is the initial size of the window, based on that preferred size of the two panels. So remember, we had created subpanel 1 with dimension 150 by 100, and subpanel 2 the same dimensions. Now usually when you add these to another panel, the default layout sets it up like this. All right. Now as you resize the window, the J-frame, it changes the layout. All right, so if you notice, in this case we increased the height of the window, and it dropped the subpanel to below it. All right, so it has this kind of free flow layout. So what we just kind of did was create these basic panels, change colors, and put on text on it, and kind of just show you how to allow for resizing and setting panels and adding components to panels and adding panels to frames. Now, the whole expectation of a graphical user interface is to allow for some user input. All right, so you allow them to click on something, allow them to enter some text, and so on. So with that interactive GUI, the main objective is to be able to capture these different forms of user inputs. Most graphical user inputs are by nature interactive. So it's expected that we be able to interact with them in some way. Now, the Swing library has a ton load of components. They have components like JTables and JLabels and JButtons that can basically make your screen a lot more interactive. So you can pop up a table, allow them to display student records, allow them to click on a student record and change information on it. So those are options. Those are some of the options that you have with using the Swing library. So a GUI in Java is basically comprised of three main objects. Right? So there are components, events, and listeners. And we kind of brushed on the components aspect. So those are any objects that you can see on the screen, right? So a JPanel is something that you can see. A JButton is something that you can interact with, and so on. Now there are other things such as events that are fired whenever something happens, and there are listeners that listen for certain events. So this kind of makes it a lot more interactive, and we'll go ahead and kind of explore some of those other objects. In Java, we have this concept of an event being fired. Basically what it means is that an event has been triggered. So whether it's a mouse press or a mouse release or so on. There are also other events apart from the mouse. There are keyboard type events. So if you want, when a user presses the button, the space bar on the keyboard, you can trigger a certain event. Or you can create events such as timers. So you can create a timer to trigger in 1 second if somebody doesn't do something. So That's another form of event that are possible in Java. Now, the event and listeners kind of work in conjunction, right? So if you want to do something based on an event, you would use a listener to accomplish it. So you'd set up a listener on an object. So let's say a button, and that listener could potentially listen out for button press, for that button press event. Now, when that button is pressed, you could trigger another set of actions, such as save the record or close the screen and so on. But events and listeners basically work in conjunction to accomplish your goals. So this diagram basically explores what I've been saying. You have a component, and components all have different events that can be triggered. You have button press, key press, so on. So what we're saying here is that we create this component, place it onto a J panel or J frame, and whenever your user interacts with that object, it can set off an event, and then a listener can respond intelligently. So when you detect a mouse button pressed on that particular object, then you can say save the record, or are you sure you want to quit, and so on. So this is how all three objects come together and accomplish interaction with your users. So when we're going about creating these Java programs, we have a series of steps that we usually do. We create the components, right? So you would recognize that you need a table to display all the different objects in maybe a database. Then you realize that, hey, you want to be able to modify each one of the table elements, so you create maybe some J text fields, and then you add a J button to trigger saves and so on. So we basically lay out everything, put it on the panels, and set up the components. Then the next step happens that we create listeners for events that we care about. We may not necessarily care that a user is clicking on a J label. That's nonsensical in some instances. But maybe another user cares about that, because when you click on that J label, maybe the user is just not understanding what's happening, and you want to put up a tooltip text to say, hey, this is what this means. There are different forms of kind of assisting the user throughout the program. Now, as I said before, when we're implementing these listener classes, it's only about the events that we care about. So we only care about if the user presses the save button, or we only care about if the user clicks on maybe a record in a table. So those are just the events that we'd care about, and we'd code for just those events. Java has a ton load of different events that we can listen out for. Usually we only use a subset of those events. Now, after creating these listeners, then we establish some relationship between the listeners, the components, and the corresponding events. So what we do is that we create these listeners, and then we say to the listener, expect this particular event to happen on that button. Now, I can sit down here and talk about it for a very, very long time, because this topic is pretty, it can be expansive, but I think it's best if you actually see an example. So the most common example of this kind of interaction, where you have events being triggered based on components and listeners, is a button. Now, a button basically allows you to trigger some action. So if you see a save button on a screen, then maybe when you click on that save button, you want it to save. So we have an example, in this case, of a button that's on a J panel, which is on a J frame. Whenever you click on that button, it just increments a counter. Really simple example, but how it works is that the push button, the J button itself, has a button press action event that can be triggered. You can then create an event listener that listens out for this particular action. So as I said before, we create, in this case, if you notice, because it's Java, we can create our own panels, right? So we can, in this case, we created a push counter panel, which extends a J panel, all right? So all of the methods that come with a J panel are inherited. So what we've done is to initialize a couple of things up front. We have a counter object, private int count. We have a button, a J button, and a J label. All right. So if you remember, if we go back on the screen, you'll notice that it has a button, a label with a value, and it's a J panel, a blue J panel. Now, what we're doing here in the push counter, in the constructor, is to initialize the count to 0, create the J button called push me, and we're adding an action listener. So this is brand new to you guys. Now, J buttons have the ability to take in listeners, or to basically add multiple listeners. So maybe you have somewhere in your code that's listening for the button press to trigger some other action. You can define multiple listeners right throughout your program for just one object, if you so desire. Now, within this class, we're also creating a label that displays the count value. So initially it starts out at the 0, and then we're adding the button and the label to the panel. Now you'll notice that we just say add, all right? But remember, we're extending the class of a panel, therefore we can add to ourselves. So by saying add, we're calling the local method of that J panel, all right? So we're adding it to ourselves. So we're adding the J button and the label to the panel itself, and then we're setting the dimensions and the background to that color. Alright, so just below this particular class, we have another class being defined. In this case, it's a button listener class, which implements an action listener. And if you remember, we went through this whole implementation and how to extend classes, how to implement an interface, and so on. Now, action listener ships with Java. Action listener is basically an interface which has a couple of different methods that need to be implemented. In this case, it only has action listener only has one method that requires implementation, which is called action performed. Action performed expects that an action event is passed to it. So all we're doing here is creating a button listener and telling Java what to do. So in this case, we're incrementing a count and we're setting a label. All right. So the count is the global count of the class that we're in, the panel class. So it can increment that and set the label. All right. So basically what happens is that whenever you click on that push me button, it triggers an event. That event is spawned, and then you hand that event to your action perform method within your button listener. All right, so it's pretty interesting. You can create these listeners that listen out for specific events. Whenever that event is fired, you are now aware of that event, and then you can do something interesting. All right, so a few key things to note. Although we spoke about it, I'll just kind of repeat it. The button listener class is defined within another class, so it's what we call an inner class. So it has certain properties. You notice that we said private for the class name. We have the private keyword and then private class something. No other classes outside of that J panel that we created can see it. Right? So that's something important, and it's usually what we call an inner class. Now, it facilitates a communication between the user and the actual objects on the screen and your code. So this is important for kind of tying everything together, right? Tying the user to your program to different actions that can happen. So inner class really should only be used whenever there are situations where the container has a direct relationship with a child class, right? So don't create an inner class and then have multiple copies of this inner class elsewhere. All right, so that's bad programming practice. What you really should do is create a generic class which can be utilized within other classes. But just because of this example, it makes sense to contain it as an inner class. It's an inner implementation detail, so it's not required by other classes. Right, so now we have on the screen what we call the driver class. Right, so it's the main class that kind of triggers everything. In this case, it's called push counter, and it contains the main for the program. So what this is basically doing is creating a JFrame with the title push counter, and it, again, you see it setting the default close operation to exit on close. It gets the content pane, and then it creates the counter panel and adds it to it, right? So we just have a one-liner that does two things, actually three things. It gets the content pane of the frame, attempts to add the panel, and it also creates the push counter panel object. All right, so three things in one line, and you'll see a lot of that, especially in GUI programming. And then the next thing that we do is frame.pack, because we want to assemble everything, and then we set everything to be visible. All right, so it results in this little dialog, and you guys can feel free to try it and run it and click on push me as many times as you want until you reach a maximum integer. All right, so let's explore text fields. In this case, we're going to have another GUI example that uses a text field to capture user input. Now, all it is that if the cursor is in the text field, then you can generate actions based on this. So as you click inside, you can then type and so on. So we have two classes in this case, Fahrenheit.java and Fahrenheit panel.java. All right, in the Fahrenheit class, this is our main driver class that has the main method to trigger everything. And here you'll see the creation of a frame with the title being Fahrenheit. We're setting the default close operation to exit on close as usual. And we're creating a Fahrenheit panel, right? So on first observation, you can guess that we're creating a panel, a Fahrenheit panel, which extends a J panel. Now the next thing that we're doing is getting the content pane, adding that panel, and packing it and setting it visible to the user. So let's look at what happens. All right, so on the screen you'll see the Fahrenheit JFrame being displayed. You'll also see a couple things. Enter Fahrenheit temperature, that is a J label. And then right beside it you'll see a J text field, right, with a value 74. So maybe a user has entered 74 here. The next thing that you'll see is a J label directly below that says temperature in Celsius :23. All right, so there's some amount of logic being applied to it and rendered on the display. All right, so just as we suspected, we have a Fahrenheit panel that extends a J panel. All right, so by extending it, we get all the benefits of a J panel plus some. So in this case, we have inside of our panel three labels: input, output, and result labels. And we also have a J text field that captures that user's input. Now, in our constructor, we initialize everything. So we have the input label that says enter Fahrenheit temperature. We have output label that says temperature in Celsius. And we have a result label. All right, so initially, the result label will have nothing on it. The next thing that we're doing is creating a J text field. Now, if you notice, we have the value 5 being passed to its constructor. That value 5 is the number of characters with that you can accommodate in that J text field. In this case, we're accommodating 5 characters. We're then adding an action listener called temperature listener to our J text field. All right. So just like the button class where we had add action listener, we can also add an action listener to a J text field. And in this case, we created our own temperature listener. Now, remember, because it's a panel, this panel that we've created extends a J panel. We can add it. We can just say add and give it input label, Fahrenheit label, output, and result label. All right, so that adds each one of those items directly on the panel, and then we just set the preferred size to a width of 300 and a height of 75 pixels. And then we set the background to yellow. Now, again, we see the use of a private inner class. And in this case, it's called temperature listener, and it implements the same action listener interface. An action listener interface requires only one method be implemented. It's called action performed. And by default, that action performed method takes in an action event. All right? Now, inside our action event, whenever any event is triggered, we're creating a Fahrenheit temperature integer and a Celsius temperature integer. Then we're getting the text of the Fahrenheit label. Sorry, we're getting the text of the Fahrenheit J text field. And then we're doing a couple of things. We're parsing it as an integer. Then we're converting it to the Celsius value. And then we're setting the label text to say what the Celsius reading is. There's a couple things wrong with this, in that the user could potentially give you a text character, in which case this will crash and throw an error. All right, so you better do some error handling. So do you try catch the conversion errors that may occur and handle it appropriately. So maybe you want to push up a dialog that says, hey, you need to only give me numbers. So far you guys have been exploring just creating panels, adding stuff to it, and so on. And we've been kind of just triggering these events and not necessarily looking or observing at the event itself. Now, this is kind of a really important part of GUI design. When you trigger an event, you really should be looking at a couple of things. Looking at the source of the event and doing something with it. So we have an example of that with the left-right panel and left-right Java classes. So let's delve into it. So the first thing that we have is a left-right class that is also a driver class, so it contains a main function that sets up everything. It has the frame as usual that sets the title text to left-right, and then it has a default close operation as usual of exit on close. We have this one-liner that does a couple of things. It creates the object and it adds it to the content pane of the frame. Right? Then the next couple of things that we do is to pack it and then make it visible to the user. So this is what we expect. We have a frame with a title text saying left, right. We have a label at the top of the screen that can potentially change to left or right depending on the button that you click. Now, directly below that label is a button panel, and on that panel contains a left button and a right button. Now, right here we have the left-right panel that extends the J panel. As usual, if we're extending a J panel, we get all the benefits of the J panel's functionality along with a little bit extra. In this case, the little bit extra is it contains a left and a right J button, as well as a J label and a button panel. Inside the left-right panel, we have a constructor that initializes everything. The left button gets initialized with a new J button with a text left and a right button that has a text right. And then we create a button listener. Now this more than likely is a private inner class, and that inner class is added to both the left and right button. Now this is slightly different from what we've done previously, where we create a listener and add it to only one item. In this case, the same exact listener is being added to two buttons. Now we also initialize the label that says push a button. Initially, when the window is rendered, it will show push a button at the top of the JFrame. The next thing that we do is create a button panel. So this is a panel being created within our panel called button panel. The button panel also has an initial size of 200 by 40 pixels, and then we're setting the color of this button panel to blue and adding the left button and the right button. All right. The next thing that we're doing is setting the size of our own left-right panel. And we do that just by saying set preferred size, because now this is a local method call, right? And this is as a result of extending the J panel. So just like set preferred size, we can also do set background, add, and so on. Now, in this case, we're setting the dimensions of the left-right panel to 200 by 80. We're changing the color to cyan, and we're adding a label and then the button panel below it. Now, again, we had created a button listener class, and this is a very specific implementation of an action listener, and it's specific to the class that created it. Inside our button listener class, we have an action performed method that takes in an event object. Now this will be the first time that you will see us using the event object. In the previous examples, we didn't care about the event object. So I encourage you guys to check out the action event class and explore all the different methods available with it. In this case, one of the methods are get source, and what that does is query the source of this particular event. Now, if you recall, we were adding the button listener to two separate objects. So the action could have originated from either the left button or the right button. And this is a little bit of code for us to check if it's occurring at the left button or the right button. If it is occurring at the left button, what we're doing is setting the label text to left. And if it's occurring at the right button, then we're setting the label text to right. You guys feel free to try out the code, but here we're just concluding this part one of a two-part series of graphical user interface development. And we're saying that, you know what, a lot of the times us programmers don't actually write GUI code. However, it is important to understand the inner workings and how to manipulate graphical user interface with code. There are two different types that I know of off the top of my head of IDEs that allow for GUI development. There are Eclipse and NetBeans. They're both free, but I encourage you guys not to do any graphical user interface development just yet in them until you properly understand how to do it in code. Now, it's 10 times easier to do it in Eclipse or NetBeans just because it allows for easy layout manipulation, drag and drop of buttons and repositioning and resizing and so on. But I encourage you guys to go and program this, all right? Now, you guys have seen how to manipulate graphical user objects and using the AWT and Swing libraries. We haven't touched on half of the different methods, the different classes that are available in the libraries, but check it out. There are lots of resources online and lots of really well developed API docs. All right, so thank you guys.